Welcome back everyone. We're going to continue down the road with enlargements in 8.4, but now we're going to talk about enlargements and areas, where the first one was about just lengths, right? So this is what we did previous paragraph, and we said, well, K, the scale factor, is the distance in an image divided by the corresponding distance in an object. The image is the new thing, the object is the old thing. Now let's check those two rectangles to the right here. If we want to calculate K, we can do that in multiple ways here, right? We take the distance of an image and divide that, this is the image in this case, and divide it by the corresponding distance in the image. Objects. This is the image, this is the object. So 1, 2, 3, 4, 5, 6, for example, divided by 1, 4, 3, or 1, 2, 3, 4, divided by 1, 2. Right? This gives me a scale factor of 2. So every line in B is twice as long as every line in A. But that doesn't hold up for the area, because the area of A is 3 times 2 is 6 squared centimeters, while the area of B is 6 times 4 is 24 squared centimeters. That's not twice as big, that's 4 times as big. Can I still manage to find out how much bigger it has become? Yes, you can. If the length and the width became twice as large, did the area become twice as large? No, but you can still calculate it by taking it K squared as large. So for example here, you can calculate the scale factor K by doing 4 divided by 1, right? Or 4 divided by 1, if you take the lengths. Now the area of this thing is 16 and this one is 1. Yeah, because it becomes the scale factor K squared as large. So it becomes 16 times as large. Now scale factor of K means that the area becomes K squared as large. Here my K was 2. So my area becomes 2 squared is 4 times as big. Hey, that happens here, right? 6 and 24. Here you start with 1. The scale factor is 4. So my area becomes 4 squared is 16 times as large. That's okay, because 1 times 16 is 16. How can you use this in actual exercises? Now take a look at the two dinosaur stickers. I don't know why they are stickers, but okay. Dinosaur 2 is an enlargement of dinosaur 1. So this is the object, what I start with, and this is the new image. They say the area of this thing is 0.92 squared centimeters. Now calculate the area of dinosaur 1. Oh, sorry, dinosaur 1 has 0.92, excuse me, and I'll calculate the area of 2. We don't know the scale factor yet of from this object to this image, but we can use our knowledge of 8.3 to calculate that, because we can take the distance in an image and divide it by the corresponding distance in an object. So some of you might take the length of his foot here and the length of this foot, or the distance from his tail to his head, as long as you take two corresponding distances. So I, for example, here took those two, the length from his toe to his head, and I take that one here as well, because that is the corresponding distance in my object. How do I find K? Yeah, well, by dividing this length with this length. I measured this was 2.8, this is 1.9, so my scale factor is approximately 1.47. So every line in this sticker is 1.47 times as big as the lines in figure 1 here. But the area is not 1.47 times as large, it's 1.47 squared as large. So we start with 0.92. The new area will be 0.92 times K squared. So this number squared. That means 1.47 squared, which will give me approximately 1.99 squared centimeters. So remember, I can find k squared by first calculating k, and therefore you should in this case first measure two corresponding distances, divide them in the correct way, and then say, well, my new area will be that squared as large. Okay? In theory B, we'll find a different way that sometimes can also work when we, for example, know the both areas. But that's what we're going to discuss in theory B. See you then.